Good morning from Washington, D.C. Good afternoon, good evening to those of you in London and around the world. Thank you for joining us today for this Zoomcast on UK-US Antarctica cooperation. My name is Rebecca Pincus. I'm director of the Polar Institute here at the Wilson Center, and I want to thank you for joining us today. The Wilson Center was established over 50 years ago to serve as a nonpartisan think tank with a congressional charter and a mandate to conduct nonpartisan policy analysis and provide recommendations. And today, we are delighted to host this event focusing on the US and UK's special relationship extending to the ends of the world. Obviously, the special relationship has been celebrated for decades. Today, we are looking at how that plays out in Antarctica, which is a region experiencing new geopolitical tensions and extreme effects of climate change with global consequences. We have an outstanding cast of speakers and only 60 minutes, so I'm going to wrap up fairly quickly so we can dive right into the content. I'm delighted to welcome Evan Bloom, our senior fellow here at the Polar Institute, a longtime senior veteran of the State Department and our resident Antarctica expert who will be hosting today's event. Again, thank you for joining us. Thank you to today's speakers and presenters, and looking forward to the great content. Thank you. Evan?
Becca, thank you very much, and thanks to everyone for joining us for today's event focusing on UK-US science collaboration in Antarctica. The Antarctic Treaty of 1959 sets aside Antarctica and its surrounding waters for peace and science. I think it's fair to say that no countries have contributed more to science in Antarctica over these past decades than the United Kingdom and the United States. Even though numerous countries operate their science programs at the poles independently, cooperation is also an important part of the key results that have been achieved, and those results are important not just in relation to Antarctica itself, but for the entire world, especially these days in the context of how polar science contributes to our understanding of global climate change. British Antarctic Survey and the U.S. National Science Foundation are the gold standard in national Antarctic programs, funding science and providing logistics that few other countries can approach. We have leaders from these programs here with us today. We also have prominent British and American scientists who will tell us about their work. And I'm sure we'll hear about, for example, the International Thwaites Glacier collaboration led by the US and the UK, which is investigating one of the world's most unstable glaciers and is telling us a great deal about the potential for sea level rise around the world. Now, the work of these two countries is also particularly important in the context of the coming international science collaboration in 2032-33 called the International Polar Year. We have with us one of the leading figures working on organizing the IPY who will tell us about this ambitious plan. So we have some very special and knowledgeable speakers today. Leading off is Dame Jane Francis, the head of the British Antarctic Survey and recently elected president of the Royal Geographical Society. She is one of the best-known leaders in Antarctic science and a key participant for the UK in numerous polar meetings, including the Antarctic Treaty Consultative meetings. Next, we'll hear from Dr. Alex Eisern, Assistant Director for Geosciences at the National Science Foundation. She is one of the most senior figures at NSF and in the USG as a whole, working on Antarctic science policy. Then we'll have Henry Burgess, formerly a UK diplomat and currently the head of the Arctic office of the UK Natural Environment Research Council. He is president of the International Arctic Science Committee. Then we'll hear from two scientists. One is Kate Hendry. She is a chemical oceanographer and marine biochemist at the British Antarctic Survey, an honorary professor at the University of Bristol, and a fellow of Queen's College at the University of Cambridge, and she has done work in Antarctica in collaboration with US colleagues. Finally will be Ted Scambros, senior research scientist at the University of Colorado's Earth Science and Observation Center. He is one of the country's most well-known glaciologists, and he's kind enough to come to us from Hawaii at 3 o'clock in the morning. And he looks quite awake for that, so that's great. With time remaining, I hope to pose some questions to the panelists. I want to thank Ellie Donnelly of the Polar Institute and the Wilson Center's IT staff for doing the groundwork to make today's event possible. So we have just 1 hour, so let's begin. Dame Jane, the floor is yours.
Thank you very much, Evan. And could you share my slides, Ellie? Thank you. So I'm delighted to be here and to talk about how we have been collaborating with the US and future potential. Next, please. So Antarctica, for those of you in the audience who don't really understand why there's so much attention on Antarctica, Antarctica is so remote, but it's the highest, driest continent, and it's more greater in size than even the US. So it's a huge continent covered in ice. It has 90% of the world's ice. You can see a NASA satellite image here, covered in ice that's up to 4 kilometers thick in places. And we know from the work that we've been doing there that if all the ice melted on Antarctica, it would raise global sea levels by at least 60 meters. And we know that what's happening in Antarctica at the moment is that it is now responding quite rapidly to climate change. We once thought that it was a big block of ice sitting on a big block of rock and fairly inert, but now we know that we've seen and made observations that the change is happening quite quickly. And what happens in Antarctica doesn't stay in Antarctica. It is affecting the whole planet, both in global sea level rise, but also changes to ocean circulation and changes to our atmosphere and our weather. So it's a really important place for us to work at the moment. And I've mentioned here the West Antarctic ice sheet, which is the thumb-shaped part of Antarctica on the westerly side, on the left side of this diagram. And this is an ice sheet that we are really concerned about. And as Evan mentioned, the Thwaites Glacier project is in that region. And this may be very close to a tipping point. Next, please, Ellie. So why the US and the UK working together? As Evan said, we are both major players in polar science, both scientific nations, and with a large company of scientists that work in Antarctica. We both are major leading logistics operators, and we have, for example, aircraft, we have ships, we have stations in Antarctica, and we have been working together on joint projects in the past, but we have the logistics capabilities to do large programs. Antarctica is a large continent. It is a huge geographical location to work in. And the science questions that we want to answer of a huge, massive nature that requires large science programs. We can't just pick at it anymore with small grants and small two-man parties as there were in the past. We need to work together, both for the scale of the questions, the scale of the science, the sharing of the scale of logistics, but also because it's now very expensive to work in Antarctica, and collaboration promotes efficiencies in sharing facilities. Next, please. Now, one of the major projects that the US and the UK have worked on and is still ongoing, the field work has just finished, is looking at the Thwaites Glacier, this Thwaites Glacier program, which is in part of that West Antarctica that I pointed out in a previous slide. And as you can see from this diagram, it is a multi-logistics, a massive epic of field programs that have taken place over the last few years. And Ted Scambos is going to talk more about the science of Thwaites. But one thing that has helped and that has contributed, once two partners get together, like the major partnership in science and logistics of UK and the US, that has brought in other nations. And so Germany, Korea, Denmark, and others have joined us in this major program, again with efficiencies and with greater science impact. Next, please. So I just want to give you a couple of other examples of major science that is ongoing, or just to illustrate the kind of major science questions that are being worked on at the moment, not necessarily yet as a partnership, but potentially in future, I think. One of the big questions that we are asking in Antarctica is what is happening to the sea ice? The sea ice freezes around Antarctica every winter and doubles its size, and it forms this huge white sort of blanket across the polar seas, which has huge influence on the ocean, on the heat budget, and particularly on some of the animals, the krill and the fishing. And if what's happening now is that we can see that that sea ice blanket is beginning to shrink, and it has drastic implications for both Antarctica and its ecosystems, but also how that relates to the rest of the world. This picture I have shows an amazing collaboration between the British Antarctic Survey's aircraft, which is flying low over the sea ice, collecting data about sea ice. And on the, you can see in the air, there's both the cryosat, the European satellite on the right, and then on the left is ICESat, the American, and they are taking measurements of the sea ice at exactly the same time. It was an amazing collaboration, and that has helped calibrate the 3 sources of data that is so rarely happens. So that was a fantastic project. Next, please. The understanding the ecosystems and how the melting ice at both poles is affecting the whole marine cycle, how melting ice is bringing extra nutrients to the oceans, how that is affecting the carbon pump. We know that the oceans around, particularly around Antarctica, is storing heat and carbon, that all that extra heat that we're generating through anthropogenic warming is being stored in the ocean. And with it, there are lots of carbon cycles, there's lots of nutrients, and that's affecting the whole ecosystem in the ocean and the fishing and all the food resources in there. So understanding that system on a large scale is also a major project that's happening in the UK, but also with many international partners. Next, please. And of course, the Arctic is also important as well. And the UK, we've just had a project in Greenland looking at glacier melt. And there has also been another project. So we do have a funding system that allows the US and the UK to work together. And I know this is in the Arctic, but this is a current project that is ongoing to look at impacts of environmental change on human colonization in northern Greenland. So we've been doing those in Antarctica as well, these shared projects, and they've been a fantastic source of funding, which I hope will carry on in future, which has been the cement that holds these projects together. Next, please. Ecosystems, again, I think there's a huge amount of potential for the US and the UK to work together, and you will hear some of the science that's going on in a joint project from Kate Hendry in a moment. Next, please. And I showed you a picture of the ship. So this is the Royal Research Ship, Sir David Attenborough. This is a new icebreaker now doing science in Antarctica and in the Arctic, but mostly in Antarctica for the UK. And the sharing logistics, I think, is the future for Antarctica, because it is really so expensive to work in Antarctica. And safety is a major, major concern of ours. So we need safe equipment. The Sir David Attenborough has 11 laboratories on there. It can take helicopters when it's needed. And it has fantastic facilities for over 60 scientists. So this is like almost like a whole university department on the ocean. And I know too that the US is changing, as the UK has done, from 2 Antarctic ships to 1 polar ship. We have been through that process, 2 ships to 1, and we've learned a lot of lessons on how to organize our logistics and how to do science. And I hope that we can join together in future to collaborate with the 2 new ships to do fantastic marine science. Next, please. And I want to tell you about one project, international project, that is being planned now, and that is called Antarctica in Sync. This is a major international project to bring together all the Antarctic nations, the 57 nations potentially that work in Antarctica, but over 20 of them have ships of some kind that we hope will be placed in Antarctica at the same time. So this really is about taking scientific observations in Antarctica, in and around Antarctica, in synchrony. At the moment, it's done a bit piecemeal. It's not done together. It's not done at the same time. But Antarctica is changing so fast that we do need a kind of baseline, a base map of Antarctic conditions so that we can understand what's happening now and then what's happening into the future. So InSync is being led by Germans, but there are over 20 nations promising to put their ships in the ocean around Antarctica. In the Antarctic season 28-29, the US and the UK are major partners in InSync, and we're in the planning stages to help develop this program and to do some fantastic international science. Next, please. It's been signed up as part of a major UN program, a Decade of the Ocean Decade, and this will be looking at the Antarctic oceans, but also all land-based science and land-based observations, atmospheric observations as well, to understand the ocean, to protect ecosystems, to understand climate change, and create a digital representation of the ocean and Antarctica, and to expand our database for future science. It's a very, very exciting project. There's a lot more to do in preparation, and I hope that the US and the UK will be major partners in this to really understand Antarctica into the future. Thank you very much.
Jane, thank you so much for that great and very comprehensive overview. And so next to the US program side, Dr. Eisern, the floor is yours.
Thank you so much. I want to thank the Wilson Center for setting up this time to share our thoughts on the excellent partnership that we have with the UK. But I also really want to thank you, Jane, for your leadership in Antarctic research and operations. You've always been a fantastic role model of creativity and grace under pressure. So I'm very, very honored to be here speaking with you. As Jane outlined, the UK and the US have had a long and very successful history of collaborative research in Antarctic science. And this has primarily been driven by shared interests in understanding the unique environment of the continent and its role in global systems. Much of this huge success, as Jane alluded to, has been reliant on our shared logistics, both on land and at sea. And we look forward to continuing that in the future. But this has really been a truly key partnership in a broader international effort to address the impacts of a changing planet. And the collaborations with the UK have been longstanding, driven through our researchers that have worked together over many years. I wanted to just start by highlighting just what I feel is very impressive is the broad range of science that's been central to this UK-US collaboration. And there's so many examples that highlighting everything would be impossible. So I tried to categorize it. But before I start, one thing that's also been a huge benefit is not only the intellectual exchange and collaboration, but also the exchange in the concepts of how we do science in the Antarctic. As Jane said, it's a very, very difficult place to work. The logistics of getting food and goods and services to the Antarctic is hard because of just the distance and the challenging environment. So we've learned so much from each other, and I think that's been such a critical part of the partnership. And many of the things we've learned have now been adopted by other Antarctic programs. So what are some of these areas of scientific collaboration? One of the most significant, of course, is really improving the understanding of Antarctic ice sheet evolution and its influence on rising sea levels. There have been many longstanding collaborations, the most recent being Thwaites, but we've worked together in Pine Island and other places. And Ted will give us a lot more detail about Thwaites in a minute. But the ability to measure ice sheet loss and quantify how that converts to sea level rise has really been an incredibly significant societal benefit that have arisen from these joint investments. And it's really provided the public with a sense of how global impacts of warming have local impacts because of the sea level rise. And it's clear that the 5 meters of sea level rise that WAIS holds, or the West Antarctic Ice Sheet holds, will have significant economic and societal impacts far beyond local and regional areas around the globe. So from a policy standpoint, it's critical that we continue to make investments in understanding the evolution and fragility of these ice sheet systems, particularly as they will continue to significantly impact not only the US economy, but global economies and also national security. But there are many other important areas of collaboration. One is collaboration around advancing climate modeling capabilities and prediction, which is so critical to our understanding our future. There's also been significant work that we'll hear more about on understanding how these changing climates are affecting Antarctic marine ecosystems and biodiversity, and research in the Antarctic Peninsula between the US Long-Term Ecological Research Project and the UK Rother Time Series have really provided us with data critical to understand the impacts on the environment so that we could advance environmental protection by establishing things such as marine protected areas, as we've done collaboratively in supporting the one established in the Ross Sea, which is one of the largest marine reserves in the world. We've also had incredibly strong collaborations in the development of new research tools and techniques, a lot of collaboration around engineering robotic, autonomous underwater vehicles and remotely operated vehicles to explore under the ice shelves, which have been critical in gathering data on ocean circulation under these shelves and understanding ice sheet dynamics. But these technologies have also we've worked together on building biogeochemical float technologies to better quantify carbon cycling in the Southern Ocean, which is so critical to understanding the increase in carbon dioxide in the atmosphere and how it will evolve over time. We've also worked together to advance technologies such as LIDAR, radar, gravimetry that have been used to map the ice sheet surface, its thickness, and the bed topography underneath the ice sheets, which is critical to their evolution. We've collaborated on ice drilling technologies to drill into subglacial lakes and drilling ice cores, but also, as Jane mentioned, collaborations in remote sensing between Cryosat-2 and ICESat-2 that are really going to be critical for getting the bigger picture of ice sheet evolution. We've also worked together on establishing the Landsat image mosaic of Antarctica, or LIMA. But we've also worked together for so many years that even all the way back in the pioneering work that was done around understanding atmospheric or stratospheric ozone depletion, or the ozone hole, was really a strong joint collaboration between the US and the UK. So we're really excited about seeing these catalyzing efforts continue, and it's clear that they will because of the close relationships that we have amongst the funding agencies as well as the researchers. But being that this is an event hosted by the Wilson Center, I thought it would be beneficial to explore the question of why is it of national importance to invest in Antarctic science? It's clear, particularly for those of us who have worked in the Antarctic, that it's critical for our economy and national security, and thus federal policy, that we understand how Earth systems are responding to our warming planet. It's also clear that the Antarctic plays a key role in many of the significant responses to warming that we're seeing. So what are some of the critical areas of Antarctic research that are most relevant to policy development? As I say, it's clear the Antarctic is an early indicator of changing climates, as we see from rapid changes in the region's ice sheets, temperatures, and ecosystems, particularly in the peninsular region. This region's changing as fast, or in some cases faster, than the Arctic. It's important to understand the underlying causality of these changes, because that underlying causality is critical for refining the predictive models that we need to develop to inform infrastructure planning, disaster preparedness, and national climate policy. Importantly, understanding sea level rise from changing ice sheet has direct relevance to the significant economic impacts that we're already seeing in the coastal zone, as well as the national security interests, because many of our military installations are in areas that are at significant risk to sea level rise. We also must learn more to understand and predict the pace of ice sheet collapse to better develop resilient strategies for coastal regions. And without these informed policy decisions, we will be unable to address the increasing risks to the built environment. It's also important that we understand how impacts to keystone species in the Antarctic environment could destabilize broader ocean ecosystems that are critical for supporting commercial fisheries and marine biodiversity globally. These Antarctic ecosystems are very unique and they're extremely sensitive to environmental change, and therefore changes in the Antarctic are going to have impacts on global fisheries. And lastly, it's important to make these investments because Antarctic research drives technological innovation, from satellite monitoring to advancements in renewable energy, autonomous systems, and robotics. And these investments are critical for continued support and scientific innovation and leadership. So I wanted to just also briefly talk a bit in the US about Antarctic support for future research. We recognize that there's right now a lot of concern in the US research community about the future of our ability to support research in the Antarctic. And at NSF, we know we need to do more to communicate the status of the US Antarctic Program Research Enterprise. As we were discussing before we started, the SCAR meeting, or Scientific Committee on Antarctic Research meeting in Chile recently, was really a wonderful opportunity to discuss more about Antarctic support with the research community. But it's clear that the situation as far as supporting research in the Antarctic, that we're still recovering from the impacts of COVID. We lost 3 seasons fundamentally, and construction delays that have resulted, in addition to the research that's backed up, has really negatively impacted our ability to deploy researchers and support personnel. This has been compounded a bit by the critical need for facilities renewal that's also impacting available resources. But we do want to send a strong message that we're committed to supporting Antarctic research and to enhancing our facilities so that we can do better in the future. Right now, the Office of Polar Programs is working with the National Academy of Science to initiate the next Antarctic decadal study that will guide future US research investments, and that we're planning to have this report completed in time for informing IPY planning. And then just quickly a bit about IPY. It's clear that IPY has been transformative for Antarctic research and really provides an opportunity to strengthen international partnerships that transcend national boundaries, such as that we share with the UK. The collaborations that are enabled through IPY is really a fantastic force multiplier in enabling research that's greater than the sum of its parts. IP-wide projects have driven major advancements in understanding the role of Antarctica in the climate system, the dynamics of ice sheets, sea ice, ocean circulation, atmospheric processes. And large efforts such as Thwaites have, again, really demonstrated that it's the sum of the parts of these projects is critical to understanding systems in a holistic, multidisciplinary manner. So the legacy of IPY also continues to influence future research priorities, making it a cornerstone of polar science and also policy making. As I mentioned, some of the research that was done during previous IPY have really allowed us to advocate for stronger environmental protections under the Antarctic Treaty System, and also the Convention for the Conservation of Antarctic Marine Living Resources, or CAMLR, and has allowed us to really push and fight for the establishment of marine protected areas such as that in the Ross Sea. And these MPAs are really going to help us ensure the future sustainable use of Antarctic marine resources. So I'd like to close by just saying it's really a time to look forward. We're really excited about IPY. IPY is really going to allow us to do the next level of moonshot programs in the Antarctic. Science is going to lead the way. So the time is really now for the research community to really start thinking about what some of these moonshot projects will be. And we're really exciting to see what the future will bring. So thank you, and back to you, Evan.
Alex, thank you so much. And thank you in particular for focusing on why the US policy community and Americans generally should appreciate why Antarctic science is so important. It's, I think, very important to explain that. So next to Henry Burgess. Henry from London, please go ahead.
Great. Thank you very much, Evan. Hopefully you can now see my slides. It's a great pleasure to be here. Thank you very, very much for inviting me. I am very much an interloper here. So I am from the Arctic community rather than the Antarctic community. But I hope I'm going to talk to you convincingly about why International Polar Year and the links that we can make together are really, really important. And this is your opportunity to get in at the basement of everything that we are doing. So you've heard from Jane and Alexandra very eloquently about the changes that are happening in Antarctica, the global impact of those changes, and the really urgent need to know more about what's happening so we can respond and adapt and be even more resilient than we will hopefully be to those changes, but particularly why there's a need for international partnerships. And that's absolutely at the heart of the plans for the International Polar Year. Good. So just a little bit about IASC, which is the International Arctic Science Committee, of which I am the president. And IASC is one of those organizations that is helping to organize the International Polar Year, together with our Antarctic counterpart, Scientific Committee on Antarctic Research, the International Science Council, and also the World Meteorological Organization, and many others as well. So I don't want to dwell on this, but we are the counterpart to SCAR in the Antarctic. You've heard a little bit about International Polar Years already, and this is the 5th International Polar Year that we're planning in 32-33. The third one of these, the one that happened in 1957-58, was essentially what created the whole of the Antarctic Treaty System. So the fact that Antarctica is given over to peace and science and international cooperation is as a direct result of what happened in the third International Polar Year, or geophysical year as it was called then. So these are very, very impactful, once in a generation opportunities, and we're very keen to to maximize the next opportunity for that. Alexandra said a little bit about what the results were of the last IPY, the one in 2007-8, but the figures are genuinely impressive. So 50,000 researchers, observers, educators, students were involved over the course of the International Polar Year from 60 nations, 230 international projects, and many, many more national ones. And for the first time, the last polar year brought together social science, humanities, indigenous communities, particularly important in the Arctic, but more broadly, and polar residents into the activity and the priorities and the setting of the initiatives within the International Polar Year. And the last one also created the whole structure for support for early career researchers in the polar regions, which is extremely important. So we've decided collectively as an international community that the pace of change in the polar regions, the threat posed in the polar regions, is such that we can't wait the usual 50 years between international polar years. So we've decided to do this next one in 32-33, 25 years after the last. And we've been involved in very cautious and careful but optimistic negotiations with all the partners you can see here to make sure that we're moving together with a focus that's jointly on the Arctic and on the Antarctic, and particularly on links and connections between those two, but connections that are global as well. The science planning for the last IPY began 4 years before the actual year itself. We're starting this planning much further in advance. And I think that's a reflection of the complexity of the world now, particularly the political complexity, but also the many more actors and people that are involved in that work. So we're giving ourselves plenty of time, but of course that raises expectations as well. I'm conscious this is quite a complicated slide, so I'm not going to go through it in detail at all. But the one thing I would like you to look at is that ramping up, that bridge on the top right-hand side of this slide. So although we talk about International Polar Year in 32-33, and what we're planning for, what we're expecting is an enormous international undertaking, a huge hit of special activity in those years. Actually, this is a build-up to that point, and then a legacy that goes on beyond it. So we hope that within a few years, we'll begin to see some IPY projects and programs already beginning to start. James talked about Antarctica in Sync, and I think that will be a classic one that's part of the International Polar Year, even if it's not happening in 32-33. And so we'll build up activity and impact and pace as we come up to these years, and then also a legacy that will go on beyond. And it was very much that sense of legacy and connection that's been part of the previous International Polar Years, and we're very keen to make sure that we have within this one too. So I want to tell you a little bit about kind of the structure, but I won't do a lot of it. But this is particularly because I want you to understand a bit about how we're engaging other groups and partners in this, so that you feel the opportunity to get engaged. It's still very early days for the planning, so we don't yet have a website, although one is coming, I hope, in the next couple of weeks. We don't yet have a logo, but again, I hope one is coming quite shortly. So there's plenty of chance an opportunity to get engaged. We will have a secretariat for the International Polar Year, a kind of a dedicated team, but we don't have one yet. We have some offers of support from the International Science Council and from the WMO, which is extremely welcome. But at some point, we will be building a wider secretariat, and we'll be extremely keen to hear from those people that want to support that process, and that will be very welcome indeed. So we have two levels of kind of planning committee at the moment, which is the executive committee, which is the Arctic and the Antarctic science committees, the International Science Council and the WMO. And then we have a planning group underneath that, which is 17 organizations. That's expanding out. We're advertising for new people to join that have international and kind of level responsibilities. And that's really important to us, because that's the way that we'll make sure that particular organizations that can contribute a lot, that have rights and responsibilities, who are stakeholders, who represent particularly indigenous communities in the North, that they have the opportunity to be involved at this early stage in the planning of the International Polar Year. We've already begun to set up 4 task groups around vision and priorities, around indigenous leadership, around country and funders' involvement, because of course the IPY will be successful if nationally and internationally we get behind it, we make connections with the research councils, we can actually put some money and some commitment kind of and access to infrastructure behind the science plans that will emerge, and then also capacity building and early careers coordination. So this isn't a final group, but hopefully you can see that we're beginning to take some of these things into account at the moment. What will happen next, essentially, in October, in a couple of weeks' time, is we will have an updated content note, basically, an updated prospectus, if you like, for the International Polar Year. That will have some of the details that I've talked about today, but also beyond, and is one of the building blocks for the next stages. So quite shortly, we'll be engaging in public consultations and engagement with stakeholders, rights holders, and others about these plans and visions for the International Polar Year, and begin to bring together a science plan, because absolutely new science at the largest possible scale with the biggest impact is absolutely at the heart of the International Polar Year planning. So if you have some thoughts and want to get in contact with us, please do. We have an interim secretariat, even though we don't have a permanent one yet, and we'd very much like to hear from you. These are our contact details within IASC, so please do follow up, and you have my contact details here as well. So I'll leave it there, but happy to take any questions in the discussion afterwards. And thank you very much. Please do keep an eye out for International Polar Year and get engaged. We need all the talents across both poles and beyond to make this a real success. Thank you.
Henry, thank you so much. And thank you for explaining how IPY is going to work. It's really what the polar science community is focusing on now as a matter of great priority. So that's great. And of course, I can't wait to see your new logo. So that will be fun. So next, Kate, we're going to turn to two important scientists that tell us about their work. Kate, you'd be first. Thank you.
Great, thank you very much. It's a great pleasure to be here today. Hopefully you can see my slides okay. So I'm an ocean scientist at BAS, and I'm here to talk to you today about some of the marine science we do, but also give some examples of valuable long-term collaborations with the US programs. So last year, BAS updated their science strategy, and we stated that our overall goals are to provide the critical information that we need about the polar regions. We need to understand how and why they're changing and what we might have in store in the future. Critically, and what we emphasize more, is that we need to deliver the scientific evidence required by decision makers in industry, policy, and society so that we can move towards a sustainable future. To understand this change, though, we need the long-term view, and that includes recent observations to understand where we're at in terms of a baseline, but also sufficiently long records so we can understand change in the context of natural variability. So BAS operates a number of long-term monitoring programs for this purpose, and I'll tell you about one of them today that I helped coordinate, and that's the Rothera Time Series, or RATS program, based in Ryder Bay near the UK Rothera Research Station off the West Antarctic Peninsula. Here we've been carrying out oceanographic observations for over 25 years, since it moved from the previous study site in the South Orkney Islands further north in the peninsula. And what we've generated is an incredibly valuable, unique data set, and that's because we have observations year-round. We go out sampling twice a week in the summer and once in winter when conditions allow us to do so. So the Rothera ocean scientists and helpers will go out in a small boat in the Antarctic summer. You can see here the water is often open, but also as you head towards late summer, they'll be able to pick their way through the forming sea ice to carry on doing the measurements. And you can see here in this image the sensor package that we use to measure the temperature, the saltiness of the water, and also the optical properties. They also use special sampling bottles to collect water for analysis for really important biological and biogeochemical parameters, such as nutrients, algae, bacteria, viruses, and so on. And in winter, if thick sea ice forms, they can take the skidoo out onto the ice, they can cut a hole and send the sensor package of bottles through this hole to keep on measuring and sampling. In more recent years, we've expanded our observations to include, for example, sea ice observations, measurement of aerosols and other properties of the atmosphere, but also the use of marine autonomy, such as this glider. This can help us measure the same properties, but at a higher spatial and temporal resolution than before, and also with a lower carbon budget. These gliders are deployed off the small boats that you can see here and can be piloted remotely from the UK for several weeks at a time. But as well as carrying out our own research at BAS, of course, the RATS program is most valuable as it's a spine on which other national and international collaborators can build their research. And we've collaborated on topics such as the cycling of biologically important trace metals, as well as climate active gases. And probably one of the most valuable long-term collaborations is with the US Palmer Long-Term Ecological Research Program, or PAL-LTER. So as part of the PAL-LTER program, scientists occupy this grid of stations that you can see on this map here every summer and carry out a wide range of physical, biological, biogeochemical observations. And I've been doing so since the early 1990s. And one of their stations that I've marked here with the arrow is very close to our RATS site. And so working together brings us a number of co-benefits. Firstly, in terms of data quality control, both the UK and US teams can cross-check their observations. And you can see here, what we've done in this image here is attach our sensor package onto the larger frame in this case on the US research vessel, the Lawrence M. Gould. And here it is being deployed over the side as well. I am a little embarrassed to admit how old these photographs are. I took these whilst I was a PhD student, invited to take part in collaborative research on the Gould. It was such an exciting moment for me because it was the first time I went on an oceanographic research vessel. As well as that, we can collaborate by bringing our complementary data sets together, as well as sharing platforms, as Jane mentioned, and exchanging knowledge and building capacity together. Here's one example from a few years ago now, where we held an international meeting in BAS headquarters in the UK, and many US scientists involved in the PAL LTER program took part. Partly out of this meeting, as well as another side event, there was a co-edited edition of the Philosophical Transactions of the Royal Society that you can see here. And one key finding from bringing our research together is that we can see differing trends in algal production in the north and south of the Antarctic Peninsula, indicating there's this coupling between what's going on biologically and the physics and climate dynamics in this region. And it's a critical finding if we're to understand the biological response to climate change. So we have to really bring together these long-term data sets from different nations in order to do so. And we're continuing our fruitful collaborations and project co-production. So for example, and more recently, we were delighted to host a PAL LTER scientist at BAS for several months in 2023 to 2024. So I'll leave it there. Thank you for listening, and I'm happy to take questions in the discussions later. Thank you.
Hey, thank you so much. That's a great presentation. Really appreciate it. And now to our second, last but not least, scientist, Ted Scambros. Please, floor is yours.
Thanks very much, Evan, and thanks to the Wilson Center for organizing this and giving us an opportunity to share some results from really one of the largest science collaborations between the US and the UK, and as Jane pointed out, several other nations. It's the Thwaites Project, the International Thwaites Glacier Collaboration, which involved about 100 scientists over the past 6 years. If you'll click forward, Ellie, one of the things that we identified early on was that Thwaites was a major focus area for ice loss in Antarctica. And the colors in this map show where the ice sheet is deflating in red. And as you can see, Thwaites is located right in the center of one of the large areas of red on the map. It's an elevation change map. It shows where ice is being lost from the continent and results in raising sea levels around the world. Next slide. Sea level around the world was a major concern and a continuing concern for the IPCC reports. One of the concerns was whether or not parts of West Antarctica in particular could begin to disintegrate rapidly. And for that reason, this dotted line above all of the other curves indicating as much as 60, 70 centimeters additional sea level rise in this century could result from a rapid retreat, basically from Thwaites Glacier, from West Antarctica as a whole, but the main processes and the main area of concern was Thwaites Glacier. That's why we put together, next slide, the International Thwaites Glacier Project. The reason that Thwaites is particularly sensitive is that it sits atop, next slide, a particularly deep area of bedrock in Antarctica. And because it's quite deep, the ocean can erode the underside of the ice as the glacier retreats and rapidly lead to the loss of ice. But there are several key processes, details in this retreat that were the topic of exploration by the ITGC, this joint project between the US and UK that began in 2018. Next slide. It's a complex system. We sent a whole bunch of folks out there to understand this system, every aspect of it, both the past history, the ocean circulation in the area, what's happening to the ice sheet, models of how it fractures, and models that try to describe how it will evolve in the near future. Next slide. And it also took a tremendous logistical effort, one that really challenged the two best operating countries in Antarctica for logistics, the US and the UK. Thwaites, as it would happen, as luck would have it, is located in one of the largest stretches of coastline without a permanent base. Between Rothera and McMurdo, there's no other major land base on the continent. So the assets of both nations were needed to place up to 60 to 70 scientists in the middle of West Antarctica through this multi-year, multi-research period. Next slide. I won't go through all of the acronyms. Suffice it to say that we covered the entire system quite thoroughly. Each of those acronyms include in its name what topic, what process, what aspect of the glacier was under study by these groups. Each of them a complex project involving two lead scientists, one from the US and one from the UK. Next slide. This kind of collaboration was really important, and it was built upon the years of collaboration that we already had. Most of the teams already had connections scientifically because of the long-standing collaborations we've had in the Antarctic and scientifically in general in the polar regions. It was a great thing to see come together. We also educated a large number of early career people or students that are now quite familiar with the processes of ice sheet decline in West Antarctica and are looking forward to working together further in the future. Next slide. This is that same cross-section profile, but it gives you a bit of an idea of how thoroughly we covered the system. And we can go forward from here. Next slide. Each of the groups studied a different process. I know this slide looks a little funny because it's a radar. It looks a bit like an X-ray, but it does allow me to summarize some of the changes in the results. At the top there, where you see the words Thwaites Eastern Ice Shelf, we were quite concerned in the beginning that the loss of this ice shelf, which is imminent, would lead to a tremendous acceleration of that side of this glacier. By the way, that entire image is Thwaites Glacier flowing from right to left into the ocean. So the width of that flow front is about 80 kilometers. Part of it fronted by an ice shelf. That's what I was talking about there just a moment ago. The central flow area of the Thwaites Western Ice Tongue moves at about 2 or 3 kilometers per year into the ocean. It's accelerating. And then this area at the bottom of ice cliff calving was a source of major concern in terms of its potential for accelerating the retreat of the entire ice sheet. What we learned is that upper and lower sections, the ice cliff area and the Thwaites Eastern Ice Shelf, appear to be less of an immediate concern for the next few decades than we thought. However, that rapidly flowing central area, we've uncovered a process that really is of great concern going forward, a process where seawater can be pumped underneath the glacier up into the grounded part of this ice sheet and erode the underside of the ice sheet well before it actually encounters most of the ocean and goes afloat. This is a critical aspect that we want to understand better in the future. We learned a lot about ice cliff calving. We learned a lot about the processes that are involved in melting the underside of the ice. It was not nearly as simple as we thought. I won't have time to go into the details. And we also learned a lot about how the ice shelf is coming apart, but also that the glacier has already responded to the loss of the ice shelf. It's no longer providing any backstress. And so that area is likely to accelerate a little, but not a lot, after the loss of the ice shelf coming up soon. Next slide. I'll let you read some of these major results we've had in the future and try to save several minutes here for some questions. We can take a look at one more slide at the end, I think. And that's just the core of the glacier and the front of the glacier here with the Palmer, the research vessel for the US, visiting the very front of Thwaites Glacier. But thanks everyone again.
Ted, thank you so much. So we do have about 5 or 6 minutes left at the end. And so I wonder if I could pose some questions, maybe first to Jane and Alex. But both of you have talked about future plans within your organizations. And I wonder if you could talk a bit more about the future of Antarctic science collaboration and how strong the support will be in your view, for funding for this. Polar science is expensive and more money is needed. What are the prospects for funding and getting the funding and collaboration that's needed to go forward in the coming decade or decades? Jane,
Shall I go first? Well, the particular program that is currently funding, has funded, and is currently funding a lot of the collaboration is joint NERC, Natural Environment Research Council, and NSF, where we can do joint programs. So we could have a postdoc joining one project either way, and that's been very successful. And I have not heard that that's going to be stopped currently. But of course, I think like all polar nations, funding is challenging at the moment. So there could be changes, but I haven't heard that that will be changed, because that is really a successful scheme. The big one coming up in future, of course, is InSync, and I hope that UK will be part of that, and that will be part of a major international program. Some years planning, and there's plenty of time for UK, US to get together to do some links to that. There is more discussion in the UK, although of course we've got a new government and things may change, but there is more discussion at the moment about having long-term vision and long-term funding, as opposed to lots of small pots of funding, because of the recognition that, you know, the really important topics in climate change and environmental change require a long-term science programs. So I hope that funding will follow some of those announcements, but we remain, and we have to wait and see if that's going to come about.
Thank you. Alex?
To support Jane's first point, I mean, I agree that the UK-US collaboration that we have set up, I think is something that we really value, and we see that moving into the future. We also see great potential, as particularly in our case, as we're trying to and rebuild some of our facilities and also catch up. There's a great resource of existing samples, existing data. And I think the potential there for collaboration that doesn't require field work is huge. There's also clearly we're going to be moving towards collaborations through IPY, but I'm really glad Jane gave such a great summary of InSync. I mean, that we were certainly internally talking a lot about InSync, and we've had meetings both at the treaty, both at SCAR, with the principles of InSync about, you know, how we can participate. So I think, you know, again, I think, as Jane articulated so well earlier, you know, the costs of doing work in the Antarctic are so high that we really are moving to a place where we need to collaborate. Plus, the research questions looking at things at an Earth system level require larger teams. And no single country can really afford to do that, or no single country really has the footprint to do that anymore.
Alex, thanks. I wonder if I could just follow up with you a bit. I mean, obviously, NSF spends a lot of time communicating with members of Congress about the priorities of U.S. science. Do you get the sense that there will be support in coming years within Congress for the enhanced budgets that are needed for IPY and other projects?
I mean, certainly that's the hope. I mean, we had last year, we were really glad to be able to reinstate our congressional visits on the ice. I think that's critical to really putting forth the understanding of the complexity of the system needed to support the research. I think, you know, on the face of it, people just don't see how everything is hard. And it was really important for us to be able to bring appropriators down last year. The plan is to do the same this year. And that really helps them spread the word amongst themselves about how critical the research is and how critical the footprint is. So our hopes are that we do feel we have a lot of support. We know budgets are hard. But the director of NSF has been very supportive of Antarctic research and supporting Antarctic facilities. So we actually are feeling very positive. And we can always do more, but we're feeling really positive at the moment.
Alex, thank you very much. And in the couple of minutes we have remaining to us, just to go back to the scientists and ask you about your priorities, Kate and Ted, as you look into in the context of the work you're doing, where do you want this work to go in the future? What are the priorities for a decade or more from now in terms of what you want to see, whether it's done by you or others?
I can go first, Kate, real quick. I think one of the main things that we can do in the near term is try to set up systems similar to InSync, where we're observing some of these areas of change in a more continuous way, having data that comes in so that we can watch these areas evolve and see how different climate patterns, they change every few years, how they affect the system. The other thing that we're looking forward to is collaborating with some of the other Antarctic operators to revisit Thwaites periodically. It won't be at the scale of the ITGC, but we can still pursue some of the questions that have been raised by the research and further understand how the retreat is likely to unfold in this century. Real quick, the ITGC really concluded that most of the models show that the retreat and the danger is real, but probably not a real inflection point in the rate of sea level rise until towards the end of this century. But we still have uncovered several processes that we need to understand further before we can be confident about that.
Thank you, Ted. Kate, any
I think
thoughts?
just really quickly, as well as working with different nations, which is really important, and as echoing everything that Ted's already said, I think also trying to break down the silos, as it were, between disciplines too. I think it's really understanding the linkages between the sort of more classical physics, chemistry, biology subject areas, where we're going to actually really understand the complexities of the natural system, and also, of course, working between observationalists and modelers to really properly understand the global impacts that change in Antarctica may have in the future.
Thank you very much. And I understand we have like maybe another minute, and therefore, why don't I go finally to Henry one more time and ask you, since you're a bipolar person here, perhaps you can talk a little bit about how IPY relates to the future of polar science and where you think it will take collaboration in the future.
Thanks, Evan. Yeah, happy to. I think genuinely one of the reasons why we've started this work so early is to give space to the scientists to have these discussions and to make these links and to set these priorities, so that we have time for the scientists themselves to genuinely pick the biggest questions that need the most international collaboration with the best possible chance of international funding. So I am not a scientist, and many of the other people who were involved in the planning at this scale are not scientists, and we won't be the ones that set the science priorities, but we will find space as soon as possible for the community themselves to set those, so they've got the best possible chance of frankly winning the money that will make the difference. And the reason we have chosen to bring forward an IPY after 25 years rather than the usual 50 is because, yes, the pace of change in Antarctica and the Arctic is picking up, but also the capacity and the opportunities to learn more in space, in remote sensing, in autonomy are changing equally quickly. So there's time to take advantage of that and predict a little bit, if we can, about kind of matching up those observation systems together with the big questions.
So Henry, thank you so much, and thank you all for all the speakers for participating in this. I think all of what you were saying makes very clear the importance of Antarctic science, as well as the important work that the UK and the US have done in that context. So I think it was been a very useful hour. So thank you all very much, and thank you to the Wilson Center support, and take care.